In one of my previous videos, we looked at the possibility of terraforming Mars into a kind of backup Earth to avoid extinction events such as asteroid impacts. And while it is very possible that we'll see colonies on Mars within our lifetime, it raises the question, why don't we ever hear about colonizing Venus? By all accounts, it looks more promising on paper. Venus is closer to Earth than Mars is. It's nearly identical in size to Earth, has a gravity very similar to Earth, and it has a nice thick atmosphere to protect the surface from harmful radiation. Sounds perfect, right? Well, our sister planet has a few flaws that make her a bit less agreeable to human life. To put it simply, if you were asked to picture a blood-soaked, nightmarish hellscape, you could very easily picture the surface of Venus. Say you were part of a daring mission to land on the surface of Venus, and you managed to touch down somewhere without dying. Spoiler alert, that's impossible, but just go with it. You hop out of your lander ready to proudly plant your flag, then you burst into flames. Then you implode. Then your lander implodes. Then your lucky block of lead melts. Get the picture? The surface of Venus is really, really hot, around 450 degrees Celsius at the equator. The pressure on the surface is unbearable, even for reinforced probes, at roughly 90 times greater than on Earth. This has caused the untimely demise of various probes over the years, with even the most successful missions being extremely short-lived, lasting around an hour at most. Okay, so surface landings are out of the question for now. Doesn't that rule Venus out for colonization? Not entirely. We just have to think a little more Star Wars. It's true that the surface of Venus is far too hot, but as you ascend through the atmosphere, the temperature begins to drop dramatically. At an altitude of about 50 kilometers, it measures a much more manageable 75 degrees Celsius. Jeffrey Landis of NASA's Glenn Research Center explains that a problem with a Venus colony stems from our preconceived notions of what colonization looks like. He says, the problem with Venus is merely that the ground level is too far below the 1 atmosphere level. At cloud top level, Venus is the paradise planet. And he's not exaggerating. Well, maybe a little bit. But the fact is that the upper atmosphere of Venus looks very promising indeed. As early as 1971, scientists began to propose various approaches to colonizing the Venusian atmosphere. More recently, we've seen proposals of what are called aerostat habitats, basically more advanced blimps or rigid airships, followed by something straight out of a sci-fi movie, floating cities. Let's start by looking at the prototype habitats. Since the Venusian atmosphere is mostly composed of dense carbon dioxide, a mixture of breathable air composed of oxygen and nitrogen could act as a lifting gas, equivalent to about 60% of the lifting power of helium here on Earth. The idea is that a large balloon full of human-safe gases could suspend a small colony or scientific outpost in midair. The balloon would be safe from the searing heat and overwhelming pressure of the surface, and would be shielded from cosmic radiation by the upper atmosphere, which has roughly equivalent shielding potential to Earth. The little floating outpost could drift along indefinitely, gathering useful information about our sister planet. Well, it wouldn't exactly drift along, as wind speeds above the cloud layer can reach up to 340 kilometers per hour. But still, there would be no harm in letting the balloon be carried around the planet on the winds. In fact, allowing the blimp to move freely rather than attempting to keep it in one place would greatly reduce structural stress from the wind. When we think about the kind of protective gear astronauts typically need to wear, you probably picture the big puffy white suit, right? The amazing thing about the skies of Venus is that colonists wouldn't need any of that heavy pressurized equipment. All they would need is a source of oxygen and protection from the occasional acidic rain and higher temperatures. As advances are made to these floating colonies, even the need for these small protective measures could be done away with. We could see an enclosed dome full of breathable air, rendering oxygen tanks unnecessary, and allowing scientists to work in relative comfort. Eventually, we could see full-scale floating cities above the clouds of Venus. Since the atmosphere is mostly carbon dioxide, it would be relatively easy to grow plants and food, after filtering out the sulfuric acid. This would go a long way towards making colonies more self-sufficient. Of course, it's not all sunshine and daisies above the clouds. There would still be some difficult problems to overcome. First, Venus is almost entirely devoid of water in any form. Those nice puffy clouds? That would be the highly corrosive sulfuric acid and sulfur dioxide vapor. Speaking of sulfuric acid, it would be absolutely critical that any craft in the Venusian atmosphere be constructed of or coated in material resistant to corrosion by the acid. Now, there is some water content in the sulfuric acid itself, but it would have to be heavily treated and filtered to be made safe for human use. Importing water from Earth or nearby asteroids would be expensive and time-consuming, but seems to be necessary based on our current understanding of Venus. Of course, even if we can solve these problems efficiently and set up thriving cloud cities, there will still be that nagging feeling pushing us to really make the planet habitable. Such a goal would require extensive terraforming, and with our current level of technology, that would take a very long time. Proposals for terraforming Venus cite 3 main goals. First, remove or convert the dense carbon dioxide atmosphere into something more hospitable. Second, reduce the scorching 450 degrees surface temperature. And finally, establish a day-night cycle more similar to that of Earth, though some studies suggest that Venus's 243-day rotation period would actually be an advantage in preserving Earth-like conditions on a terraformed Venus. Most proposals intend to reach their goals by freezing most of the planet's carbon dioxide and introducing large amounts of hydrogen or water, both of which Venus desperately needs to become more human-friendly. But these plans are a long way off, especially given the public's unending interest in terraforming Mars. So, for the time being, we'll have to be content to wait for our cloud cities. Then maybe someday, once we've established thriving colonies above the Venusian clouds, we can brave the elements of the surface, and truly start to make Venus our home away from home. If you'd like to learn more about Venus and its potential for hosting life, check out the links in the description. Make sure to subscribe if you haven't already, and leave a comment down below with what you think of the idea of cloud cities. If you enjoyed this video, be sure to check out my other space-related videos by clicking here. Or if you've got some time to kill, you can watch all of my videos by clicking here. Thanks for watching, and I'll see you in the next video.
When we consider human colonization of other planets in the solar system, the primary focus is Mars. And that's understandable. It's close enough to the Earth that we could make regular crew and supply trips to it. It has frozen water beneath the surface, we can land on the planet, it has a 24-hour day, gravity that would be much easier to work in when compared to somewhere like, say, the Moon. Numerous robotic missions on the planet have proven that science equipment and habitats will be able to withstand the Martian temperatures and atmosphere. Though we can't terraform Mars right now due to the lack of sufficient amounts of resources like CO2, we can certainly build habitats and domed colonies there. Mars is the first obvious choice for building a human presence beyond our homeworld. But why is it that our sister planet Venus is so often overlooked? Can we colonize and possibly even terraform Venus? That's what we're going to explore in today's video. Before I begin this video, check out our sponsor, Private Internet Access, a VPN that keeps you safe and secure online and keeps no records of your online activity. Without a VPN, your internet service provider can see every website you visit and your data is not secure. It's even worse when you're using public Wi-Fi hotspots. What's more, the internet is becoming incredibly fractured by geographic restrictions on websites and video content, especially since the passing of the EU's GDP regulations. Private Internet Access protects your data online and lets you bypass these geo-restrictions by using IP cloaking. It also lets you block malware, ads, and trackers. It's available on a variety of operating systems for mobile devices and desktop computers. Be sure to check out Private Internet Access today from the link below and stay safe online. Venus is actually slightly easier for us to send probes to than Mars. It requires less delta V and the launch windows are more frequent. There's also a few other interesting factors to consider. Venus is much closer in size to the Earth than Mars. Venus has a mass that's more than 80% that of the Earth's, and with a diameter that's 95% that of the Earth's. So if you were to put them side by side, you'd see that Earth isn't much bigger. Consequently, the surface gravity on Venus is 91% that of the Earth's. So what's the problem with Venus? We've sent probes there in the past. Why does Mars get all the attention? Why aren't we making serious plans to send humans to Venus? Well, while Mars may not exactly be paradise, conditions there are downright benign when you compare them to Venus. Venus is the closest you're going to get in our solar system to a literal hell. Venus is a world shrouded in a thick layer of cloud, several kilometers thick, composed mainly of sulfuric acid. The surface isn't visible from space. There's been over 20 missions to Venus. Only a couple of them have actually landed on the planet. In 1970, the Soviet Venera 7 lander was the first probe to land on another planet, and in 1975, Venera 9 returned the first images from Venus's surface. The probes didn't last too long, functioning for less than an hour on the surface before the corrosive and hostile atmosphere would have rendered them inoperable. Venus has an atmospheric pressure 90 times that of the Earth, which is like being submerged in an ocean on Earth at a distance of about 1 kilometer. The toxic atmosphere is composed primarily of carbon dioxide. As Venus and Mars both fall short of the Goldilocks zone that Earth inhabits, Venus may very well have had liquid water on its surface millions of years ago. As it stands, it's now a hellish and volcanic world, and thanks to its sulfuric clouds, a global greenhouse effect has taken hold, which help to produce average surface temperatures of about 462 degrees Celsius. So that's hot enough to melt lead, though not hot enough to melt steel, nickel, or titanium. Therefore, the probes may still be somewhat intact on the surface, though significantly corroded due to the punishing atmosphere. As you might imagine, these conditions don't exactly lend themselves to being a welcoming and enticing prospect for human colonization. But it actually gets worse. Venus rotates so slowly that its day is actually longer than its year. If you wanted to design the most inhospitable world possible, you'd be hard-pressed to top Venus. But hypothetically, could it be terraformed? Could we actually radically engineer the environment to become Earth-like? It's practically impossible to do it on Mars, now that we know there's insufficient CO2 there to increase the planet's temperature and atmosphere to make liquid water stable on the surface. By comparison, Venus has an abundance of CO2, but while Mars is far too cold, Venus is far too hot. There are some outlandish terraforming proposals out there for Venus, but they would require even more sophisticated technological solutions than those required for Mars. So to call it a long shot is quite an understatement. But let's run through some things you'd have to do to potentially make it work. The first is reducing the temperature, which is even harder to do than warming a planet. The various processes required to terraform a planet are interconnected, so beginning with removal of the atmosphere would help to begin the process of cooling Venus. In 1994, American astrophysicist James Pollock and Carl Sagan proposed crashing an asteroid 700 kilometers in diameter at 20 kilometers per second into the planet because it could help to eject large amounts of the atmosphere into space. NASA scientist Jeffrey A. Landis calculated that 2,000 such impacts would be required in order to reduce the atmospheric pressure to that of the Earth. This is a well-documented proposal, but I'll include links in the description box to some sources for further reading. Given the literally astronomical variables involved here, the success of this outlandish plan requires unimaginable levels of coordination and precision at a level of technological capability well beyond where we are today. This is 24th century Star Trek fantasy at this point. Once the atmosphere is reduced, the next process would be the introduction of hydrogen in order to facilitate the production of organic compounds to help convert the CO2 into oxygen. But the biggest challenge, of course, remains the temperature. Venus may very well have succumbed to the greenhouse effect due to its proximity to the Sun. The planet receives twice as much sunlight as Earth, and if we're going to try to achieve and sustain Earth-like temperatures on Venus, that would require yet more futuristic science fiction levels of engineering. One such far-fetched idea is to construct either a series of giant mirrors in space to reflect much of the sunlight, or a massive solar shade that would be placed at some point in between the Sun and Venus. Obviously, the diameter of the shade depends on its distance from Venus. What futuristic and super durable material will be needed to construct such an object is still very much open to debate. Needless to say, this shade would require resources and materials sourced and mined from elsewhere in the solar system in what would be the largest and most elaborate thing human beings would ever have constructed. The goal is not to blot out the sun entirely, but partially. Not only would this reduce the solar wind issue, but also serve as a makeshift replacement for a magnetic shield. There's one final major hurdle in making Venus more like Earth, and that's its rotation. As I said, Venus rotates far too slowly. While an Earth day is 24 hours, a day on Venus is 5,832 hours, about 243 Earth days. This is not exactly ideal for animal and plant life. So, to deal with this, Venus's rotation would be increased by yet more technologically innovative solutions that are far beyond our capabilities at present. One possibility would be to somehow fling one of Jupiter's moons, or indeed the planet Mercury, in the direction of Venus in a close flyby, and then bringing it in line as a new moon of Venus. Venus doesn't currently have a moon, so I guess that would be nice. This could accelerate its rotation, but again, the efficacy of this plan is contingent on a series of astronomical factors and variables that are difficult to accurately predict. Aside from the fact that we don't currently have the technology to move moons and planets around the solar system like shooting balls around on a pool table, as to whether we'd be able to bring Venus to something close to 24 hours in day-night rotation is anyone's guess. Terraforming Venus is completely impractical, but it is hypothetically possible if you believe in magic-like technological capabilities we're not even close to inventing yet. As for colonizing Venus in its current state, in some kind of habitats, living on the surface in any capacity is out of the question, obviously, but apparently we could live in the clouds. Yes, another pie-in-the-sky idea. This one, quite literally. NASA's Jeffrey A. Landis produced a paper on this in 2003, and he says, although the surface of Venus is an extremely hostile environment, at about 50 kilometers above the surface, the atmosphere of Venus is the most Earth-like environment, other than the Earth itself, in the solar system. It is proposed here that in the near term, human exploration of Venus could take place from aerostat vehicles in the atmosphere, and in the long term, permanent settlements could be made in the form of cities designed to float at about 50-kilometer altitude in the atmosphere of Venus. At an altitude slightly above 50 kilometers above the surface, the atmospheric pressure is equal to the Earth's surface atmospheric pressure of 1 bar. At this level, the environment of Venus is benign. Above the clouds, there is abundant solar energy. Temperature is in the habitable liquid water range of between 0 to 50 degrees Celsius. Atmosphere contains the primary volatiles required for life: carbon, hydrogen, oxygen, nitrogen, and sulfur. Gravity is 90% of the gravity at the surface of Earth. While the atmosphere contains droplets of sulfur acid, technology to avoid acid corrosion are well known and have been used by chemists for centuries. In short, the atmosphere of Venus is most Earth-like environment in the solar system. Although humans cannot breathe the atmosphere, pressure vessels are not required to maintain 1 atmosphere of habitat pressure. In other words, you won't need pressurized spacesuits.